Hello everyone. My name is Yash, and I'm someone who is interested in learning data science for a variety of reasons, some of which were my own fault. I always procrastinated and wasn't wasn't able to get the thing going, and so these streams are a way of holding myself accountable and. These are, these streams are a way of holding myself accountable and being consistent. Already I'm failing at that. I just was seeing an ophthalmologist and stuff, like for my cataracts and what have you. So those were the reasons I couldn't stay consistent, but I'll try to stay consistent. uh, so these streams, today in this stream we will be trying to learn SQL, sorry, through this Udemy course. Mm, So I've already completed some of it, but just for the sake of these videos, I'll go through some of it again. So we will go with the fundamental stuff. So the one thing that keeps coming back again and again is this select statement. So we will understand what that is.
Welcome everyone to this lecture on the select statement. Select is the most common statement used in SQL, and it fundamentally allows us to retrieve information from a table that exists within a database. Later on, we're going to be learning about how to combine the select statement with other statements to perform more complex queries. So what's the actual example syntax for a select statement? Well, after opening up the query editor, what we're going to write for our most basic select statement is select column name from table name. And you'll notice that in general, we capitalize the SQL keywords. This actually isn't 100% necessary. SQL will still run even if you don't capitalize these, but it makes it much easier to read what are the fundamental SQL syntax statements versus what are the column names or table names that you're yourself editing, depending on what you actually want. So the most basic syntax here is we choose a column name from a table. So let's see how this actually works within PostgreSQL. So we already know that we have a database, and then we right click on that database and we open up that query editor. In our case, it will be.
So let's do that. I've already this is the database, the DVD rental, and where is it? So the query tool for this is where most of our queries will be written. Yeah, this is where most of our queries will be written. So that's the, you have to first download the database and get it going, and then you make it so.
The example DVD rental database. And so the way PostgreSQL operates is inside of this database, you're going to have some number of tables. Here we have an example of 3 tables. And recall that each of these tables is essentially like a spreadsheet. We have columns and then rows of data. And here I've just made up some data. So each of these tables has columns 1, 2, and 3, so C1, C2, C3, and then rows with made up information. When we actually say select column name from table name, PostgreSQL essentially reads this a little bit backwards. It first has to decide what table you're referencing. It already knows what database you're referencing because that's how you open the query editor on that database. So it takes a look at what table name you're looking at, and then it's going to take a look at the corresponding column name. So, for example, we could say select C1 from table 1, and it would look something like this. It's actually grabbing column 1, and it'll return back that entire column, and X, Y, and Z. If we want to select multiple columns from a table, we can say column 1, comma, column 2, etc. You just separate out the column names by a comma. And keep in mind, these don't need to be in order. So if you only wanted column 1 and column 3, you would just say select the names of your columns separated by commas, and then from the table you want them in. If you actually want all the columns from a table, you can use an asterisk symbol in order to request all the columns from a table, essentially just asking.
That's true.
To your first challenge steps, we'll have a quick challenge just to test. We'll first start off with a translate inside situation, the actual sequence. I'll give you now to our existing customers.
Send out promotion email to our existing
Which means
customers.
we're going to need some information. So let's go ahead and translate.
Okay, so basically, let's see, these are the tables we have, yeah? These are actor, address, category, tree, customer. This is the customer. And let's see, this is the customer table. And these are the columns we have. This is customer ID, store ID, first name, there's the email. So this is what we will do, yeah? Select, where is this? Select email from customer. You have to get this public out of it, and then shift and enter. Oh, sorry. F5. You press F5. These are the emails of the customers that have the customer, the existing customer. That's basically it. So let's go with the another one, the select distinct.
Welcome back, everyone, to this lecture on select distinct. Sometimes a table contains a column that has duplicate values, and you may find yourself in a situation where you only want to list the unique or distinct values in that column. The distinct keyword can be used to return only the distinct values in a column. The distinct keyword operates on a column.
So I think it's self-explanatory. You basically, if you have repeat customers, and for that reason, the amount of entries that are for emails of repeat customers. Now, if you pull up the column of the emails, there would be repeat entries, and that makes the data inefficient. Suppose if you link that column for another purpose in the programming as well, that would make the program inefficient, and that would make the query process inefficient. So that is why select distinct, the distinct keyword, it eliminates all the repeat entries, and so you are left with distinct values. So let's see the challenge.
Welcome back, everyone, to this quick challenge to test your skills on select distinct calls. We'll go over an example situation corresponding to the USA. They're from Australia, and so they're not familiar with the motion picture associated.
Visitor isn't familiar with MPA movie ratings. We want to know the type of ratings we have in our database. Okay, so let's see. This is right here, film, and we columns, and we have ratings. Okay, so this is rating, yeah. So you replace, oh sorry, uh, select ratings from fill. You do this and you run this, and you have multiple. See right here there are R, PG, PG-13. So basically you want distinct. We are not interested in all the ratings of all the movies. We are interested in the scale, just like how many ratings do we use, right? So select distinct film. You press F5 and these are the ratings, that PG-13, NC-17, R, G, PG, right? So that's how distinct works. I think it's self-explanatory. So let's go with another one. Now this is count.
Welcome everyone to this lecture on the count function. The count function returns the number of input rows that match a specific condition of a query. We can apply count on a specific column or just pass count and then an asterisk. We will soon see this should return the same result because count is merely reporting back the number of rows returned, which is going to be the same regardless of what actual column you're looking at. Let's see a simple example. Here again we have that table with a couple of names and then their color choice. Let's imagine we called select count name from table. Notice here count does need the parentheses because it's a function acting on something. So it won't work without the parentheses. Keep that in mind. If we were to count the number of names from table,
This is basically what it is saying. So we have select distinct. Let's see, let's experiment. Even I'm not sure this will work or not. If I go count I don't know if this will work or not. Let's see. Even I'm not sure this will work or not. Let's see. Oh, it won't. See, we have a total of 5 PG-13, NC-17, R, G, and there was one more. So this is what that is. Like, we can do this. You can already make some guesses about how you can use this. Yeah.
just asking for how many rows are there in the name column, which is going to be 4. So the result will be count 4. So again, it's simply returning the number of rows in the table. In fact, this should really be the same regardless of the column we call, because each column has the same number of rows since they're literally in the same table. Which is why, whether you call select count name from table, select count choice from table, or select count asterisk, which is just saying select the count of all the rows for all the columns in the table, they should all return the same thing. Since the original table has 4 rows, that means each column has 4 rows, which is why you usually just see an asterisk from the table. Now keep in mind, it's sometimes useful to use a column name instead of just providing an asterisk, because if you come back on your SQL query sometime later, it may actually help kind of stir the memory of what actual question you were trying to answer. So again, because of this, count by itself simply returns back a count of the number of rows in a table. And count is usually much more useful when combined with other commands, such as the distinct command that we already learned about.
We just did this right, yeah.
Imagine we wanted to know how many unique names are there in the table. So, to answer this question, we need to first decide the distinct number of names. Then we'll provide count on that result of distinct name from table. So the logic that's going to happen is distinct is going to figure out what the distinct names are. Here it sees that David is duplicated, so it's just going to count the remaining rows. Select count this. It won't tell you what and again, of this. However, samples in pgadmin. Okay, here I am at the query editor in pgadmin. Let's select everything from the payment table.
I think that it's self-explanatory enough. Like we will go with like the where statement, which is like.
Welcome back, everyone, to this lecture on the select where statement. In part 1, we're just going to be learning the basic syntax structure, and then in part 2, we'll actually jump over to pgadmin and code out some examples. So the select and where statements are really the most fundamental SQL statements, and you're going to find yourself using them in almost every SQL query you do. So the where statement allows us to specify conditions on columns for the rows to be returned. The basic syntax would look something like this. We decide on what columns we want back, so we'll say select column 1, column 2, etc. And then we decide what table we want those columns from, and then after that, we can describe conditions. So we'll say where, and then some manner of conditions. So let's actually go into detail of what those conditions.
Okay, so basically what he's saying, let's see if I have this right. It has been a while since I've done this myself. So let's see. This is what we're going to do, yeah? Let's say okay. So select, let's say this is the title of the film, from let's say film, right? Film, and you go F5, right? These are all the films. Now how many entries are there? There are like 1,000 films. Now let's say that you want to let's see what are the corresponding ratings of these films, right? So you go comma and you go ratings, right? And then you run this, and these are the ratings. Now this is where the where statements come along. So let's say that you want to know all the movies in the list which is R rated, right? So this is what you do, where rating is equal to R. Let's see if I'm right or not. Sorry. There you go. So like, see, let's see how many movies do we have that are R rated, right? See, in 195. So in total we have 195 movies that are R rated, and you can do this for all sorts of things, yeah, right? Let's copy this and we will paste this when we have something new, right? So let's go. So we have 195 movies that are R rated, right? So let's go again. This, instead of R, let's go PG-13, right? PG-13. You press F5, right? Now let's see how many films that are PG rated. We have 223 movies that are PG rated, PG-13. So this is where the where statements come. You basically this is how you pull out the data, right? This is how you establish a query, and using where statement you qualify that query, you qualify that statement. Like this is how you get qualified to be pulled up. That's what where does.
Are like. The where clause appears immediately after that from clause of the select statement, and then the conditions are used to filter the rows returned from the select statement. And PostgreSQL provides a variety of standard operators to construct those conditions. And I want to make it clear that the conditions we show here are available in any major SQL engine, so it's not just unique to PostgreSQL. So we first have the comparison operators, and the comparison operators allow us to compare a column value to something, essentially allowing us to answer questions or queries such as, where is the price greater than $3? Or where is the pet's name equal to Sam? So those kind of statements of greater than or equal to or less than, those are the comparison operators. And you're probably familiar with the base syntax operators, at least the operator syntax signs, because they're just basic math. So for example, if we want to check for equality, we just use the equal sign. Then we also have the greater than and less than sign, the greater than and equal to signs, and then even the not equal to. And there's two ways of doing not equal to in PostgreSQL. You can have a less than and greater than sign right next to each other, or the more common way is to do an exclamation mark and then an equal sign. In addition to those, we have the logical operators, and that allows us to combine multiple comparison operators or effect of comparison operators. So you're also probably familiar with these ideas of and, or, and not, and they essentially allow you to use multiple comparison operators. So you can do something like condition 1 has to be true and condition 2 has to be true, or condition 1 is true or condition 2 is true. And then you have the not operator, which essentially means the opposite of whatever condition you're specifying. So where this condition is not true. So let's actually walk through the very basic syntax of what this would look like. And we'll do this with the example table we saw before, where we have some names and some color choices. So in order to get back both columns from the table, we could just say something like select the name, choice columns from table. So now let's try to get only the people named David. So there's a condition there where I want the name column to be equal to the string David.
I think that you guys get the idea. Let's go with part 2 of this.
Lecture where we're going to head straight to pgadmin and code along with a couple of examples just to give you an idea of the different use cases for select, where, as well as comparison operators and logical operators. Alright, let's begin by exploring the customer table. I'm going to just select everything from the customer table so we can explore it quickly. We'll say select, and then asterisk from customer, semicolon, go ahead and run this. And I can see there's a customer ID column, a store ID, first name, last name, email, an address ID, some active boolean, whether or not that customer is active or not, so true or false, the date they were created, last update, and then also an integer corresponding to the active boolean, so ones and zeros for the trues and falses here. Okay, so what can we do here to start filtering out customer information? Well, maybe something I want to know is who has the first name Jared? Maybe someone comes to the store and asks me, I'm looking for some customer named Jared, so I can say select all.
Let's do some exercises. I think like by doing this we will have a better idea of what all of this is. So let's do some exercises.
Learn how to understand a realistic business question. One of the challenge to more
this is the one
realistically
thing that I appreciate about this course. Like the
model a typical
challenges
task
are,
you would see
by
as a
itself is
SQL
very
developer
interesting.
in a real-world workplace. So what I mean
Like
by that is
I've taken some different SQL courses. One of the things is like how boring it gets. Like there is something like very tangible about the exercises that he gives. Like it's like it gets my brain going. It's like I'm genuinely curious about these answers.
from now on, our challenge examples will focus more on something like how many customers have the first name Jared, instead of asking a question such as you select what on related. Continue to learn more about SQL. Realize there are usually many different ways to write instead of our example from started. To show you some hints, if we'll go over the
this
business
is actually
situation
important.
hours, but as long as
that there are multiple ways to get the same results in programming in general. no, this is not like exclusive to SQL. So don't you shouldn't be worried about whether your results, whether the way you went about it is right or wrong. You should first see whether it got the results you were looking for. There are other things that you have to worry about, whether your code is efficient or not, because it's very important that your code is efficient, because the more processing speed it takes, the more not profitable your code will be to those who are trying to hire you, right? So that is why it's important, but that is not something you should be worrying about now. I used to be one of these people. I still am to a certain extent. I'm giving you advice, but I still commit these mistakes sometimes. But yeah,
You're getting the same expected result, then you're totally okay. So let's get started. So we'll go over the business situation in question, show you the expected result, so show you some hints if you need them, and then show you our solution.
Okay.
So the first challenge, a customer forgot their wallet at our store, and we need to track down their email to inform them. So the question is, what is the email for the customer with the name Nancy Thomas?
Okay. So this is what we will do. Select okay, so select email from customer. So let's make this a little more comprehensive, right? So we will copy it and we will cut it. Let's see what happens first. These are the emails. Okay, this is what we are going to do. We will also go first name and last name. Okay, so Jared, Eli. Okay, so this is what we will do. Yeah, you paste this and you take out, first you take out where first name is equal to Nancy. That was it, right? So you go this way, like, let's see, there you go. So Nancy Thomas @ Sakil Sakila customer. Yeah, that's how we got our result. You could do this with a
So we open up
last
the wallet,
name.
we see that their
There
name is
are
Nancy
many
Thomas,
ways to do
and we
this.
want to figure out what is the email at sakilacustomer.org. Okay, here come some hints if you need them. So our solution for challenge number 1 was to select the email column.
This is like this is why I displayed it like that. Like, if there were, like, suppose we did this and there were multiple Nancys, then you can qualify it again, right? So what they went by was that they could add and last name is Thomas.
From the customer table where first name is equal to Nancy and last name is equal to
This
Thomas.
is a more qualified statement, right? Because, like, suppose there are multiple Nancy, there's a Nancy Brown and what have you. So with this, where first name is equal to Nancy and last name is equal to Thomas, now you are like, yeah, now you become very specific.
If you take a closer look at that customer table, you'll realize that there's actually only one person with the first name Nancy, and That means you could just technically go off the first only one person named Nancy Thomas's, which means we'd probably have to send multiple emails. Okay, here comes challenge number 2. So, a customer wants to know
the movie about. Could you give them the description for? Okay. So let's go. Film description. Okay. So you take this out. You know what? We might as well get in the habit of writing the whole thing by ourselves, right? What happened? Yeah. Okay. Select description from film, right? Okay, so so these are the descriptions. Let's go with title. So this is the title description. Now if we go by so these are the movies and these are the titles, right? So now we go where title is equal to, what was it? Outlaw Hanky. What the fuck? Outlaw Hanky. Outlaw Hanky. It's capitalized. Let's see if it works. So F5. Outlaw Hanky, a thoughtful story of an astronaut and a composer who must conquer a dog in the sky. The crazy thing is, I think this is actually a movie. What the fuck? Who must conquer a dog?
what the movie Outlaw Hanky is about. Could you give them the description for the movie Outlaw? Alright, to use the film column. So challenge number 3 is a customer is late on their movie return. And we've mailed them a letter to their address at 259 IPO Drive, and we should also call them on the phone to let them know. So what we want to do is, can you get us the phone number for the customer who lives at this?
Okay. Again, we will. Okay. Select select address ID. Oh no. Yeah, this is address. Oh, okay. Okay. Select phone and select address. From address. So these are the address and these are okay. So this is how we will qualify it, yeah. Where address is equal to, what's the address? 259 iPod drive 259 iPod drive. Let's see what. Yeah, there you go. This is the number. Don't call it.
Address of 259 iPod drive. Alright, here comes the expected result. So the expected answer for challenge number 3 should be this phone number
So
here.
let's go with what
Here
is
comes some-
order by. I think that this is also like self-explanatory, what it does at least. How we use it, we have to.
Welcome back
learn
everyone
right
to
now.
this lecture on order by. You may have noticed that PostgreSQL sometimes returns the same request query results in a different order, meaning you may have run the exact same query on your computer and saw the results in a slightly different order than what I have on my computer. So, in order to alleviate this issue if we want the results in a certain order, we can use the order by to sort rows based on a column value in either ascending or descending order. So that would be alphabetical for string-based columns or numerical order for numeric columns. The basic syntax for an order by statement would be as follows. We select whatever columns we want from the
Okay. I don't know if this will work, but I'm just doing it just to see if it will work. Select. Okay. Select title, rating from film, where, oh no, order by ratings. Okay. Let's see if it works. Wow. There you go. I mean, ideally, I wanted R rated to be the last, and I don't know why it is doing this. Like it's putting all the NC-17 movies at the last. So I don't know if that's like an alphabetical thing that we have to do something like specific to get it to get the rating like that. Okay, let's try. Let's see if it changes anything. Like this is what it was when we didn't do anything. Let's see. Now we go ascending. It's still the same. Now we go descending. There you go. Okay.
table, and then we decide to order by a specific column. And then optionally, you can add in ASC or DESC, whether you want that ordering or sorting to be ascending or descending. Notice the order by towards the end of the query, since we want to do any selection and filtering first before finally sorting. So that means order by is going to be towards the bottom of a query and one of the very last things that SQL actually performs. So we're going to do all our selection, all our filtering. If we use a where statement, that should come before the order by, and then right at the end we'll go ahead and do any sorting. And you use ASC to sort in ascending order, DESC to sort in descending order. If you leave it blank, order by just uses ascending by default.
Sorry.
Now what's also interesting is you can use order by on multiple columns. So this makes sense when one column has duplicate entries. Let's take a look at this example database, or example table really. We have 3 columns here: company, name, and then the sales for that individual at that company.
We have multiple
Notice here that we
companies.
have duplicate entries under company. So if we were to actually order by two columns here, we could select the company column, the name column, and the sales column in that order from this table, and then we order by company and then order by sales. What does that actually mean? Well, it means we sort everything first based off the company column. So notice we have Apple coming in first in alphabetical order, then Google, and then Xerox. And then the corresponding names also get lined up. However, we can then also order by the sales. So after you've done the sorting based off the company column, which makes sense because there's duplicate values there, within that particular company, we do a second ordering, which is by the sales column. So note the sales now is in an ascending order for each individual within the same company. So we see Andrew with 100, and then Zach with 300. And then for Google, we see Claire with 200, and then David with 500. So if you have duplicate values in a particular column, and you want to sort not just by that particular column, but another column as well, it makes sense to do an order by with multiple columns. And it's going to sort based off the order you provide. So it'll order by company first, and then by sales. Let's go ahead and explore some more examples in PG Admin on the DVD rental database. Okay, here I am inside of PG.
Let's go with the another. This is the limit function. It just basically limits the amount of entry you want. He will explain it better than
Welcome back, everyone, to this lecture discussion on the limit keyword. The limit command allows us to limit the number of rows returned for a query. It's useful for not wanting to return every single row in a table, but only view maybe the top few rows to get an idea of the table layout. Limit also becomes extremely useful in combination with the order by statement that we just learned about. Limit goes at the very bottom end of a query request and is the last command to be executed, because essentially what the limit does is after you're done filtering with the where statement, ordering with order by and sorting, and any other sort of conditions or any filters you want to do on your query, the limit is just going to say, all right, how many rows do you want at the end of the day? So let's learn the basic syntax of limit through some examples. This should be pretty straightforward, and let's jump over to PG Admin. Again, first what we could do is just select everything from the payment table. So I can say select everything from payment, and I get this variety of payment IDs, customer IDs, staff ID, rental ID, etc. And then I also get a payment date, which is a timestamp without a time zone, essentially just a day and then the hour, minute, and then second and milliseconds where this payment actually occurred. What we could do is order by this payment date in order to see either the oldest payments or the most recent payments. So what I could do is say select everything from payment and then say order by payment date. And if we run this on a timestamp, what's going to happen if we refresh this? Notice we get 2007-02-14. So this is in American formatting, meaning it's year, month, and then day. And if I want, I can either order this by default ascending to get 2007 to and then 14, or essentially 14 rows of something is in the payment keyword, and then provide how many rows do I actually want. So if I just say 5, you'll notice here that right now it's returning everything. If I scroll down, welcome back, everyone, to your set of challenge tasks regarding order by as well as situation. So your first challenge task, we want to reward our first 10 paying customers. So the question is, what are the customers?
Okay. So first 10 paying customers. Select from, let's say, customers, right? So what do we get? Customer ID, store ID, We want to reward our first 10 paying customers. Okay. Order by customer ID. Okay. Customer ID, right? So customer IDs limit 10.
Customer IDs of the first 10 customers who ever created a payment. Up next is the expected result. So the expected result are these 10 customer IDs. Here comes some hints. So the hints are these. The first 10 customers who ever created a payment. Up next is the expected result. So the expected result are these 10 customer IDs.
We go by store ID, does that work better? Or does this work better? Store ID. Let's do this, like create date. Okay, well. That doesn't make sense. Where am I doing it? Ordered by create date. Okay, like let's go with he'll have to tell me. I don't get it.
Here comes some hints. So the hints is to use the
payment. Oh yes. Yeah. Okay. Select from payment. Okay, let's see if it works. Let's see what we get. Payment ID, customer ID of. That was embarrassing. Edge. Select customer ID from payment. Order by payment date, payment date, limit 10. There you go.
Limit table, and you will need to use both order by and limit. And remember, you may need to specify ascending or descending on the actual payment date column. Here comes the solution and table, and then you're going to order by payment as that. So the next challenge task is a cut.
I want to quickly rent a video to watch over the short lunch break. Where what are the titles of 5 shortest films? Okay, so let's go with, you might as well write the whole thing. Select title, length, from film, order by so, and now that we know that it is legit, let's see, the longest movie is 110. That's not actually no, that's a long movie. Limit 5. Okay, 46 minutes. That's barely a movie.
Customer wants to quickly rent a video to watch over their short lunch break. What are the titles of the 5 shortest, that is, in length of runtime, movies? Okay, here comes the expected result. So the expected result are these 5 movies, and if you want, you can see the actual length of those movies as your desired result. To select from film regarding this, we actually run this query of selecting title. So something I want to point out here is if we actually run this query of selecting title length from film order by length ascending limit 5, there's 2 things to notice here. One is that length is also highlighted, basically telling you later on we're going to discover that length itself is actually a SQL keyword, so we want to be careful on the way we use it. In this case, it'll work fine if we run this because it is a column name inside of this table. But something to keep in mind is you should try your best to avoid column names that match up with SQL keywords. And PGAdmin alerts you to this with this highlighting. Now, one way to just make it clear whether or not you're using a column name or a keyword is the capitalization. So from the capitalization, it's quite clear that length here is a column name and not a SQL command. The other thing to note here is I actually don't know for sure if there's more movies that have a longer or the same runtime. So notice here are the 5 movies that PostgreSQL return that are ordered by length in ascending order. So here are the 5 shortest movies, 46 minutes each. But there actually could be a 6, 7, 8, 9, etc. more movies that also have 46 minutes in length. So we don't actually know for sure if these are just the 5 shortest movies. We could have more. And what we could do is keep expanding on this limit, and then eventually we would see that the next limit in length has been reached, 47 minutes. So it's by coincidence that there's only 5 movies with the shortest runtime of 46 minutes. But just saying limit by 5 doesn't actually guarantee you that there's only 5 movies here with the shortest runtime. So keep in mind of that sort of issue that may arise when you're trying to solve a question like this. Okay, and finally, let's give you a quick bonus question. So here's a quick bonus question, no hints or anything for this one, just quickly. If that previous customer can watch any movie that is 50 minutes or less in runtime, how many options does she or he have? Keep in mind.
Where length is less than equal to, no, that's a greater than equal to, less than equal to 50. What he has, how many options? He has 37 options. Okay. Let's see if we are right.
And you may actually not even need order by for this. So again, we're just asking how many movies can that cult is 37 movies. And hopefully you can recall back to your select and where statement. So here's the solution. Welcome back everyone to this lecture on the between keyword operator. The between operator can be used to match a value against a range of values. So for example, we can ask, where is a value between a low and a high? And this is essentially going to be a condition you can tag along with a where statement. You should note that using the between operator is essentially the same as asking individually where a value is greater than or equal to low and a value is less than or equal to high. So note that the low and the high here are both inclusive. So it's actually including the endpoints there. You can also combine the between keyword with the not logical operator, essentially asking where is the value not between low and high. And this is the same as asking value less than low or value greater than high. Note here that we are exclusive of the actual low point and high point. So what I mean by that is for the not between statement, if you're saying something like value not between 8 and 9, if a value happens to be 8, it's not going to be included in the not between. Versus, if we take a look back at the between statement, that is inclusive. Meaning if you wanted a value between 8 and 9, it would actually include 8s and 9s there. So keep that in mind. And if you want to change exclusivity versus inclusivity, you can just go back and use the AND operator and then specify less than or equal to manually yourself with the comparison operators. Now the between operator can also be used with dates. You should note that you need to format dates, in this case in the ISO between keyword with the not logical operator, essentially asking where is the value not between low and high. And this is the same as asking value less than low or value greater than high. Note here that we are exclusive of the actual low point and high point. So what I mean by that is for the not between statement, if you're saying something like value not between 8 and 9, if a value happens to be 8, it's not going to be included in the not between. Versus, if we take a look back at the between statement, that is inclusive. Meaning if you wanted a value between 8 and 9, it would actually include 8s and 9s there. So keep that in mind. And if you want to change exclusivity versus inclusivity, you can just go back and use the AND operator. Now, the between operator can also be used with dates. You should note that you need to format dates, in this case, in the ISO 8601 standard format, which is essentially just 4 numbers for the year, a dash, then 2 numbers for the month, a dash, and then 2 numbers for the date, or the actual day. So that means it would look something like, where is the date between, and then as a string with single quotes in that particular format, year, dash, month, dash, day, and then the other dates. Something to keep in mind is when using the between operator with dates, that also include timestamp information, so not just the actual day, but also the hour, minutes, and seconds. You should pay careful attention to using the between operator, especially since we have that issue of inclusivity versus exclusivity of the not between. So you should take into account the fact that a date time, that is both the date and the actual time information, would start at 0-100 hours. So that may have an effect depending on what the actual situation is and whether you want inclusivity or exclusivity around that midnight time or 0-100 hour time. Later on, we're going to study more specific methods to actually work with date time information types, so don't worry about it too much right now. It's just something to keep in mind for the future. Let's go ahead and get some quick practice with the between operator in pgadmin. Okay, here we are at pgadmin. What I'm first going to do is check out the payment table, since that's what we're going to be working with for our examples. We'll say select from payment table. We'll grab everything, but just limit it to just a few rows so we can see the general syntax here and general columns. We have the payment ID, customer ID, staff ID, rental ID, and then the amount and the payment date. So we're going to be working with these 2 columns here. Let's go ahead and see if we can use between on the amount column. Let's imagine we wanted to know the actual number of payments that were done between $8 and $9. So what we can do is say select from payments where amount between 8 and 9. If I just run this, it'll give me all the results, so we can see everything here is $8.99. And if I actually wanted to know the total number of transactions, I can just count the number of rows returned, and it's 439 rows. If I wanted to know the opposite, essentially everything that wasn't between $8 and $9, I can simply add not between 8 and 9. I can run this, and then I get the number of payments that were not the date column. Payments that happened on the select everything, so we can get an idea of what's happening here. And we'll say where the payments date column is between, and what we're going to do here is make sure we format this correctly, which is going to be the year dash the month dash, let's say 01, and we'll say 2007 dash 02, and then the 15th. So we run this here, and we can see all these payments happen between the 1st of February 2007 and the 15th of February 2007. Now, something to keep in mind, especially when you're dealing with timestamp information, is that this timestamp information includes both the date and hour, minutes, etc. So that means PostgreSQL essentially has to decide, does a day start at 0-100 hours or at 2400 hours? And if you're dealing with exclusivity versus inclusivity, that actually might affect your logic. So what I mean by that is take a look at the results here. They all actually happened on the 14th. So if you kind of scroll down, you'll see there's 27 rows, and essentially all the payments that happen between the 1st and the 15th all happen on the 14th. Now let's actually switch this to be all the payment dates from the 1st to the 14th. And this is where students often get confused. They would actually expect to see these results. But if I run this, you'll notice nothing gets returned. And that's because when we're dealing with this end date, it's actually only going up to the 0-100 hour mark. It's not going to the end, which would be the 2400 hour mark of the 14th. Which is why for these sort of between statements, when you're dealing with timestamp information, you just have to be careful of that. So you always want to double check and make sure you're getting the results that you expected. So in this case, I'd have to go all the way to the 15th to actually include information that happened on the day of the 14th. Okay, And later on, we're going to learn a lot more about how to deal with timestamp information such as this. So that's it for the between examples. Coming up next, we're going to learn about more SQL keywords. Welcome back, everyone, to this lecture on the in operator. In certain cases, you want to check for multiple possible value options. For example, if a user's name shows up in a list of known names. So instead of having to write a bunch of or statements, such as name is equal to David, or name is equal to Claire, or name is equal to Zach, we could use the in operator to just create a condition that quickly checks to see if a value is included in a list of multiple options. So you can check something like, where name in Zach, David, and Claire. So the general syntax would be something like this: value in, and then a bunch of options. So, for example, an example query could be select the color column from table where color in red, blue. So note here that the options are in this little list in parentheses, and then we use the in operator to basically specify that we're checking for the color condition that happens to be either red or blue. So these are a bunch of or statements. So anything red and anything blue will be returned to us.
Let's check both of them, yeah? Let's go. Let's go with city. City, country ID. No. First name, last name. Okay. This. If we have to do this. From where first name in let's see, is it case sensitive? Let's see. Yeah, it's case sensitive. If we do this, I think we will get more results like this. Yeah, it was case sensitive. Yeah. So this was in. Let's go with between. Where last update wait a second. Copy, cut, F5. Okay. This and this. What's the point? The whole thing is just like everybody updated on the same time. What the fuck? Category. Language. Column language ID. Payment. Let's do payment. Okay. Let's see if payment date happen. Yeah, it does happen on different dates. Thank God. Okay, this is what we will do. Where payment date oh man, I have to type this whole thing all by myself. Okay, let's see if it works. Let's see if now it works. Oh, thank God. Wait a second. Oh, okay. Let's change this. It should limit it, right? Yeah, it did. Okay, it is working now.
And we can always expand this to more options quickly. So we can say now where the color is red or blue or green. So essentially there's a little or statement in between all of these. Welcome back everyone to this lecture on like and I like. And really it's more than just these two keywords. This lecture is about using pattern matching with string data. We've already been able to perform direct comparisons against strings, such as where first name is equal to John. But what happens if we want to match against a general pattern in a string? That enables us to answer questions such as all emails ending in @gmail.com, or all names that begin with a capital A. The like operator allows us to perform pattern matching against string data with the use of special wildcard characters. So there's two main wildcard characters we're going to cover right now, and that is the %, which matches any sequence of characters, so essentially any number of characters, and then there's the underscore, which matches any single character, essentially a wildcard for just a single character inside of a string. So let's see a couple of examples of this. We'll start off with the %. So the % is a wildcard character for any sequence of letters or characters. So this basically specifies something like all names that begin with a capital A. So we would say we're name, like, and then a string where we have the capital A and then the %, essentially saying you'll match up anything that starts with a capital A and then has any number of sequence of characters after it. Then we could do something like all names that end with a lowercase a. So then we have where name, like, and then we start off with the % and end with a lowercase a, essentially saying that anything or any sequence of characters can come before that lowercase a. Notice I've been saying things like uppercase or lowercase, and that's because like is case sensitive. However, you can always use I like, which is going to be case insensitive.
Okay.
Now using the underscore will be case insensitive.
Okay, so basically what this is saying select first name from actor where first name equal to I like let's see if it works. It's bad, it didn't work. What the okay. Let's see.
End with the lowercase a.
Okay. Where first name I like We have a total of 23 J's. Okay. Let's go with general challenge. I think we understood that.
Hello everyone, and welcome to your first general challenge
This guy
lecture.
sounds sick.
So I'm really excited for you to take on this first general challenge because these general challenge tasks are going to utilize all the skills that you've learned so far.
Sorry about that, people. Sorry.
You'll receive the general challenge task, and then you'll get hints of the challenge and then the solution to the challenge. These challenges are going to be a little more difficult than what you've seen earlier, so try breaking down the problem into individual tasks in order to solve the task completely. So let's go ahead and get started. Your first challenge and business task that I want.
How many payment transactions were greater than $5? So select from payment. Okay. So where amount 5. Wait a minute. Okay, so right now the total number of transactions Okay. So let's see. It gives us the output 3618. How many? 3618.
The answer is this. How many payment transactions? How many? So go ahead and pause the video. The payment table in order to the solution. Count, amount, get a couple of concepts of count, and then how many actors for?
Where is the answer?
Along with some couple of concepts from the payment. Okay. See it? Moving on to the hints. So you'll need to use the payment table, and you'll also need to use count and where, along with some that in mind. Okay, coming up next is the solution. So the solution is actually pretty straightforward. You want to select, count, amount from the payment table where the amount is greater than 5. So that's taking a couple of concepts, just the general concept of selecting from, that very first thing we learned. Those were compared an operator to filter out which amounts we were looking for. So again, that was select the count amount column from payment table where amount is greater than 5. Remember to put that semicolon in to end your query. Okay, next business task. How many actors have a first name that starts with a...
Okay. Select count. From actor where first name I like let's see 5. Let's see if we even wrote the right syntax first. Okay, we got it. There are a lot of Lokis in
letter P. Coming up next is a hint, so go ahead and... So you will need statement to review the that percent sign or under knowledge. So selecting all the rows, you can see an asterisk. First name column, capital P. So go ahead and is one challenge is how many unique districts are our customers from?
Select should we be using payment? Yeah, we should be using payment. Payment amount, payment date. No, let's use customer address. Address. Let's go with address. Address ID district. Okay. District.
ऐसे बढ़िया अपन आगे कर ला जो है ना हम लोग जाते हमारा वो सब ना कुछ कर दिया तो ये जाति बता दे इतना दूर में तो सन्नाटे ना तो काम कर जाते
Address 603.
How many unique districts are our customers from? Okay, coming up next are some hints on how to solve this challenge. So here comes the hint slide. So you'll need to use the address table, and you'll also need to use count and distinct. So go ahead and review the distinct lecture in case you don't remember how to use distinct. But you'll need that in order to solve the challenge, which was how many unique districts are our customers from. Okay, so coming up next is the solution. It's going to grab the district of Alberta, and that this district called, and then answer of how many districts, or unique districts, are the customers from. And you have to get that from the address table. Okay, so one more challenge. I want you to retrieve the list of names for those distinct districts from the previous question. So this is going to be a really similar question, but I just want you to make sure you really flesh out your understanding. Be a really similar question.
Oh, from the get-go, I wrote address instead of. I should have written district from the start. Previously, I did something. I missed a step.
But I just want you to make sure you really flesh out your understanding fully, and you should really only be editing basically one district from customers are from. Here is how many films have a rating of R and a replacement cost between $5.
Select from film. Replacement cost. Okay. How many films have a rating of R and a replacement cost between where rating and replacement cost between what it is 5 and 15. 5 and 15. $52. Let's see.
And $15. That's how many films have a rating of R. Querying skill. So the hint is you'll need to use the film table, and you may also need to use between and a where statement with some sort of comparison operator in order to solve that issue of between that $5 and $15. Hopefully the word between earlier was a clue for you for you to figure that out on your own. But coming up next was to select count asterisk, so just select the count of all the rows from film where the rating is equal to, is between 5 and 15. Notice I don't have
one of my biggest like the thing that gives me anxiety is if I've studied something and then like I'm not able to do it, like it's like frustrating. So
put strings between 5 and 15 because they're both just numeric data types. Okay, so let's go ahead and break this down just a little further. Sometimes it confuses people why you have to just select count asterisks here. Asterisk doesn't matter. So rating is equal to R and the replace. So another challenge. This one's going to be maybe a little trickier, testing your pattern matching skills. How many films have the word Truman somewhere in the title? So that's how many films have the word Truman somewhere.
This is tricky. Select title from film where title like Truman. Let's see. Yeah, 5. Let's see if we get it right.
Or in the title. Okay. So coming up next are some hints. Go ahead and pause the video now if you don't want to see those hints yet. And you'll also need to use like with some sort of wide understanding of how to use it. Here it comes. So the solution is to select count at where. But remember the question asked, if we just go back 2 slides here, it asked how many films have the word Truman somewhere in the title. So not at the beginning, not at the end, just anywhere in the title. And that means we had to use wildcard operators on both ends of Truman, meaning and any sequence of characters can come after where the title is like, and then single quote, percent sign Truman, percent signs. You found those challenges straightforward, a little.
So yeah, we have done this section. Tomorrow I'll do 2 streams for SQL, SQL as you call it. Tomorrow we will study group by statements. We will study. When I say we will study, it means I will study, and hopefully there will be people who are interested in studying it with me. Yeah, like, these streams are just a way for me to be consistent, and I'm someone who struggles with consistency and stuff. So yeah, and most importantly, this is a way for me to show the people who themselves struggle with discipline, and people who struggle with staying consistent, that you are not alone, and if we can just stay consistent, we can achieve the goals that we want to achieve. And so if you're someone, hopefully I can demonstrate it to you that we can do this. So yeah.